Okay, well, if you saw on Instagram, I did this CAD this morning. Well, over the last couple of days, I pecked away at this just to make sure I had exactly what I wanted. But I wanted framing to bend plywood around to create a 120 inch or a 10-foot diameter circle. And I had racked my brain on what we could form this around, doing layers of half-inch plywood. So 3 layers of half-inch plywood with the seams staggered would create a 1.5-inch wide curved rim joist, where a floor system would have a square floor system would have 4 individual rim joists. This is one homogeneous piece that's working as a rim joist for us here and supporting and tying together the ends of all these joists that are in a circular array rather than in some kind of a rectangular array basically going on. And that's because if you look here is the ring of the top of the smaller wall below, and so these are stacked on that in such a way that it falls in the same position in every one of them, rather than if you had, a straight line of typical floor joists. The last couple at the outside wouldn't actually be doing anything besides jumping from one edge of the circle to the other without actually bearing any load, and so you can get deflection under some circumstances or bounce. Anyway, it just wasn't going to be the right way to go about it. And so these are all in here at the exact same 22 and 13/16 of an inch from the center of every one, or at 23 degrees all the way around this circle. But if you can imagine the 3 here between the ones that are at 90, if all 3 of these came completely into the center, and trying to organize and nest and fasten all 3 ends of them would have been a big pain in the butt. So I headed them off in all 4 quadrants with one, easy 36-inch long piece with 45-degree cuts on the ends that fit in between the 90-degree components, and had these all off. And so I realized that building this framing would be exactly what I need if I can get all these ends in these positions at 23 degrees or this distance apart. If I can create this whole thing and set it on the floor, probably on a tarp, I could start strips of plywood and just screw them into the end of one of these and curve them until I've passed the last one that I'll go by, and I can screw them into that. And then I can cut it on the center line of the end of that joist and start another piece and just keep working my way around, and then start putting more layers on and get all done, build the rim joist on the actual framing. So I just went out and I had a look at this and realized that 117-inch long pieces in a pair for this component, because I want to be able to cut this thing in half when I'm done. And so if I end up cutting it here and cutting it there, I'll have one strong back or half of the beam tying the 2 ends of this half of the rim joist together, and on the other half I'll have the same thing. So we had double layer in this aspect, single layer in this aspect. 2 117-inch long pieces, a couple 57-inch long pieces, and so that made an order for 3 10-foot long sections. And then all the rest of these are a little under 4 feet, so if I needed 6 12 pieces, I could get 6 8-footers, and I get all those out of it. So I got 6 8-foot sticks, 3 10-foot sticks, and then 1 2 3 4 of these are 36 inches long with acute angles, so I got one 12-footer to get all 4 of the basically 3-foot long pieces out of, because I know it'll be a little bit longer than 12 feet by a little bit. And complementary angles, if I'm putting 45 on the one, I got a piece left on the material to start with and call that the 45-degree cut on the other. So 1 12, 3 10s, 6 8s, and then I looked at the lumber order for 2x8 or 2x10, and it was almost $100 difference between the two, so we opted for the 2x8. So here we are. One of the other nice things about this is that the frequency of this polar array for the joists is the same as every one of the studs in my wall from below. So all I had to do was make these pieces correctly and evenly and equally, place them on and attach them where the drawing tells me they need to be attached. And I did have to monkey around with this a little bit to get things to come in exactly where they needed to be. But once I did that, Matt's working over there, but he helped me set it up on top of this. And then I took a look at the 2 90-degree components, the ones that go completely through the center, this one and the other one. And I tapped this thing around until, while completely aligned on this stud, I had the same exact overhang at all 4 points, which is about 13 3/4 of an inch. And once that was the case, then I threw a screw through the side of it. Where is it? I guess that's the only one I didn't do. I threw a screw through the side of those, and then I could just walk around and justify each of these, just move it back and forth until it's either right on the chalk line on this plywood, or right on the seam between this sheet of plywood and that next piece of plywood. Chalk line, seam, chalk line, seam. And I got them there all the way around. And the last thing I can do is check for that center line to center line to center line and compare it to what's on the drawing. It should be quite close, and make sure of that, or make little tiny adjustments to make everything as perfect as possible. And what I'll do is I'll throw this junker 2x4s on here just to control that. So we are screwed to this lower piece right now so that I can screw these on and just keep them out of the way of this circle that's going to be coming around here. So I may cut this long end of it shorter, but I can screw through each one of those into each joist, which will hold it exactly where it is now. Then I can remove these, and we can pick this piece off of here again, and it'll be completely rigid. Every one of these, instead of being wiggly like they were when it went up there, will be totally rigid, and it can sit flat on the floor. And finally, we've got the strength that we need here in 2x8s. We didn't need to go to 2x10. Because we're doing such a tiny span. We're right under the middle of it, and each particular joist is right on top of a stud. It's excellent structural integrity, so we didn't need that 2x10. But I want to see a thicker floor, and so what we can do is we can make our curved joist taller than the 2x8 dimension. And so if I'm ripping up sheets of plywood, I can rip I think 5 strips of 9.5 inches out of a 4-foot wide piece. So at 9.5 inches, I'm the dimension of a 2x10, and I'll get 5 total strips out of a sheet with no waste, and then it'll just hang down a couple of inches, and the appearance of this thing will be as though the floor is that much thicker, but in reality it's just constructed out of 2x10. And so in the end, we'll use the sheets of plywood that we already owned. We'll be really economical about how many strips we get out of those pieces. We'll do that only after Matt's done doing the cardboard cutting that we're doing on them, because they're protecting the stage for us right now. And when we do this on the floor, obviously the edges of them will sit flat on the floor, and so it'll stand too tall. It was what it'll look like as we're assembling this thing. We'll be screwing it into the ends. It'll be standing up taller than all of these. And what we'll do is either we'll leave it on there and flip this thing upside down and set it back on here, or we'll just be using screws to hold it while those layers glue together. And then there's a chance that we can take screws out and completely remove the glued circle or slide it up and down in this thing, which is less likely, but it is a possibility. And it's also to be determined how far we'll take this. So I'm going to do that all as one piece, even though we've got 2 components on these sides, so it can be divided when we're done here. And so it'll go right on by here and be laminated in one whole piece. And so when it comes strike day, will be the first time that I make the cut through the whole thing, and take one half of this whole thing away and take the other half of the assembly away. So I don't want to put undue stress on a seam by cutting it right away. The glue can set, the screws can stay buried, and it can live for a couple of weeks at least in a whole homogeneous circle before I even bother to cut it. And I may even make some big gusset pieces or something to fortify these inside corners here and at the other end before I do cut it, so that we put our absolute best foot forward on keeping it from going and ripping out of the end grain and stuff like that. So long story short here, the way that we're making our custom curved joist is that we're building it right against the framing first. And therefore we drew the framing in CAD so we could be sure that the final product is exactly what it is that we wanted, and that we could get creative and make it life easy rather than running these all into some kind of nexus conglomeration of fuckery in the middle of this thing. And overall, the other thing I did is I went up and stood on the outside of this just to see if it was tippy before we added weights to this, and it's not tippy at all with me anyway. We're going to have a couple more people on here, so in the end we'll probably end up putting weight in the bottom to counteract it tipping a little bit, but I'm pretty enthusiastic about this thing to start with. And we'll have a cool 7-foot diameter rolling base that we can put other sets and stuff on in the future when we're done here. So we'll have 2 hemispherical flats, a 7-foot diameter base, and some short blocks and stuff, and that loop and things that can be used for other stuff in the future when we take this thing back down to its component parts. But Matt is working on cardboard components for the roof of this tower. Where's his drawing? It's over here. He's calling it the Pizza Hut roof, which is pretty exactly what it is. He's made that piece, and now he's got our crescent pieces that he's laying out. There they are here. This is they're bulkheads. The crescents are like bulkheads. They'll be glued to this piece, and then we'll use them to hold the surface of the tower out. And then we'll get those cardboard shingles and put those on. I'm fixing the director's parents' coffee table that somebody broke the leg off of also while we're at it. And these other trees have got their strips on them. Just checking on those quickly. I did soak an entire sheet of felt with wood glue. What I'm thinking now is I'll get the whole piece wet with water and wring it out so it's damp, and then it'll be easier to roll because I threw it onto a tarp and rolled glue into it. But rolling wood glue into dry felt was kind of a pain in the ass. I'm going to get the felt wet and then wring any loose water out of it. Then roll it full of glue on the floor and then set it up on here. But it has created like we were talking before for point load and puncture strength. I mean, I can't drive a pair of pliers into it. It's really, really nice and tough. It wasn't ultra sticky, so I did have to use some staples to hold it. I'll probably either pack them in tight or pull the ones that are real loose out. But overall, I'm really excited about it. I did like to see this ultra tight inside corner that we were getting with this glue and towel method, and it was pulling up or sitting up out of that a little bit. So over here, I sliced it to see if I could get it to sit down in there, because I knew I could repair this. Now that I can see right in there and see how far it really doesn't have any more to go, I think it's just an optical illusion, and the plane between here and here is frankly right where that felt is, and just because there's this ugly crevice, it's just a product of that being such rough geometry. So anyway, I think the felt is the way that we're going to go on these. It's going to keep them good for strong, for a long time. Now it's just a question of getting through, getting enough felt on all of them. I got a good price on it. It was 50% off Joann Fabrics for premium felt. I got the whole bolt over here. So it's just something we're going to have to get a few more hands on and just do it all in one day, because it goes really quick, but it's not the type of thing that I want to spend 4 or 5 hours doing. It's just kind of a hassle, especially since I've been playing. I mean, I did all this stuff myself, and it's been quite a bit of time getting this far, probably 8 hours. 8 straight hours, maybe 10 or 12, when you look at all the time spent working out just exactly what we want to do with this. So now that we're decided it's time to act. All right. Okay, so real quick, although sometimes these go longer than I expect, we got one course of Luan plywood to do this bend. The other stuff was just breaking, and it was older. I think if we had brand new sheets, like I was talking about being just a month old or something, they have enough moisture content at a thicker sheet to do this bend without failing, because it was about to do it, just as it was about to land, it was cracking. And it's just ancient stuff from the basement. And it was something I wanted to use because that 3/8 half-inch sheet isn't Luan, so it doesn't make sense to skin things with. And we've only got a couple of the sheets, so when we're skinning with Luan, we're going sheet after sheet after sheet, and then you add an extra thick sheet, it just makes a weird edge. On the other hand, it's not thick enough to really do a span between joist systems or floor systems or anything like that to create a walkable surface. And if you don't have to walk on a flat surface, you often don't even put one there, or you won't see it from the house. So anyway, they're weird thicknesses to have in the just on storage for forever. And I was just so happy to use them up in this circumstance. So just a tough pill to swallow that it's not going to work for this. That's okay. We're going to use some Luan. But the next problem is, and this all started with how to do a lamination in this circle diameter. And where to find a circle to build it around or to clamp to, because even if I found a vessel or a cylinder or a tank or something like that to be able to apply these to and do the gluing, not only would it be trapped and have to slide up and off of that thing when we were all done, I also can't screw into or clamp to hold it. And then we arrived at, well, I can draw the framing in CAD and make the framing, and then we'll just build it against the framing. But to start with, you need to have one contiguous circle surface, and then you have something to clamp the rest of the layers to, because before that you can't clamp to this thing, okay? So to start with, I was fine with anchoring with screws into the ends of every one of these that are on their mark and stuff, and seeing that it does a nice, I pulled my tape on these, and it's a pretty nice circle. And in the end, it doesn't have to be a perfect circle, but I'm just looking for the edge of it not to have interruptions or wiggles, so it's pretty damn good. The next problem, though, is now when I apply a layer and glue it up, I'm trapping those screws in there forever. And not, I guess, the end of the world, but we started clamping, and you start seeing that, to start with, there's 8 clamps here. I might be able to find 8, scrounge 8 more, and bring another 8 from home or something. But, excuse me, I just had something to eat, but it basically isn't going to help us to hold every little bit of edge together. And you wouldn't believe it, but any little discrepancy here, and even in that edge, you can kind of see that there as I do the bend with the phone camera. It's not exactly perfect. If your eye can follow it, just varies a little bit right there. And I don't know really how to encapsulate this concept with words, but essentially nothing's absolutely perfect, and usually my stuff is quite close given all the other factors, because I know that this type of thing haunts you if you haven't got everything just so. Theoretical things like making many strips of Luan 9.5 inches wide and applying them layer after layer here, going around this circle and getting them to glue up with wood glue and fit tightly together and become a lamination is just asking a lot, you know, of those materials without getting problems where, like for example, these vertical clamps, I guess there's just the one anymore. Anyway, I was having a problem where following the edge of the first layer, by the time I came around here, it was wandering down. But when I pull it up, then you get a layer that doesn't want to sit tight to the first layer. The second layer doesn't want to sit tight to the first. So I employed these, you know, I went down to the office basically and got half a dozen cases of these binder clamps just to see if I can get enough. I'd really rather have spring clamps that have more pressure, but these will work in a pinch, no pun intended. Anyway, and so you'll see I just did one piece. To start with, it's all the clamps and all the binder clips that I had access to. And secondly, I may not love this, and I don't want to overcommit and do it everywhere. I also used screws in areas that I couldn't clamp that will be removed. And so going forward, while screws may work to temporarily hold stuff down, they'll be removed before they're covered with more layers. And so what you end up with is a multi-layer rim joist that's anchored from the undermost layer with a screw into the framing, and all the subsequent layers on top of that really haven't been pinned through. But then if you come back and you want to put two screws from the very outside of this and get through everything, you've got to avoid those, because if you burrow down and encounter one of those, it'll immediately strip the hole that you've got and you'll have to relocate it. Not the end of the world, but basically what's happening here is it's going to take a lot more doing to build up layers. I said I didn't mind going down to 1/4 inch because it just meant doing a few more layers, but I can only do 1/4 of the circumference at a time now. So we'll do this much tomorrow morning. I just can't trust it within the same day to be I'd love to think that I could come down, glue it, clamp it, and then about midday, or you know what, I could probably go all day, and right before I leave, I could do another glue and clamp and then get 2 operations done in the day. But that would mean tomorrow at my very best, I get 2/3 or 2 more quarters of the way around this circle, leaving the last one. And then when we get all done doing the last one, we'll still only have 2 layers, and we'll have to do 2 more, frankly, for me to feel good about this. So anyway, that might just be the case. We may just have to plug away doing that. Here's the leftover negative of the 3-layer cardboard lamination. And that will be used to build some other stuff out of now that we've got that much available material. Not to mention we've got some loose sheets that can be glued up as well. And we've got some other stuff we're going to build for the show out of cardboard. But we got the footprint of the roof section for the tower and the 3 main crescent sort of bulkheads, or there's another word for this, profiles or whatever, and then the bulkheads in between them, and everything tacked with tape. And then we just pumped all the inside corners full of construction adhesive. It ended up being 3.5 tubes worth of the PL Max Premium, which is just really nice stuff, but it's like $12 or $13 a tube. So that's, you know, $40 or $50 worth of glue, and I don't know, you know, $20 or $30 worth of cardboard. So it's $100 sort of material cost at this point. And from here, I think I'm going to ask for another bulkhead here and there to bisect this area and there. So 4 more bulkheads. And this is the type of project where we'll get this far, we'll glue it and let this become rigid. And then we can do a little bit more. We'll pull the tape out of the way and get those last little areas glued. I'll probably put some, you know what, that's a good use for that 3/8 or that 1/2 inch plywood. I'll put some plates of it in here that will allow us to hang this thing and anchor into the wood. It'll get glued down on the inside of this thing, and then we can screw through from the outside. But I want to to be careful about where I place it, how large of a piece to use, so I'm not adding unnecessary weight, and to translate its location to the backside in marker or something that's indelible or whatever. And so in the future, when you're looking for something to get a hold of to hang it, you know where you can and can't screw it and get a hold of it with something good. And so with that stuff added, then we'll skin this area. And finally, we'll skin that lower area. And then we've got the cardboard shingles. They've been making those. I keep talking about it. I feel like they're around here somewhere. Here they are. Over here, maybe? Like this. So you pull the paper off of one side, which is a good project for the kids. And it doesn't matter if you leave chunks of this like they've got it here. Areas where it doesn't quite come off perfectly or anything like that. There's just so much visual. It's practically free. It's great busy work for anybody that wants to help with the show, and they can be used and reused to a certain extent if you just stick one or two staples through them to hold them. You can do washes of color. You could spray them all a dark tone and then dry brush the top of it to get all that texture to pop out of it again. And they're just a great way to finish a big surface rather than illustrating shingles or brick or whatever. So anyway, we're going to put those up onto this just once there's one solid skin of cardboard, then those loose pieces will be stuck to that with probably just staples or maybe glue. Anyway, I threw the sandbags on it to hold this down because the lamination sheets were doing a bit of an arch from the way that it dried, so this will hold them perfectly flat to the floor. And when all this glue dries up, then it'll be like arrested in that kind of flat shape, which will help it hang and not be wonky. In fact, I might go out with just this and hang it up from a bar just to see whether in profile it hangs vertically or wants to kick the bottom out or back. Sometimes it depends on where you get a hold of something. Oftentimes it's nice to get a hold of it toward the bottom and then run the line along the back or along a vertical surface for quite a ways and trap it there also. And so basically it forces the line for that far to hang vertically, and a lot of times it'll cause the piece to hang vertically. So without too much more blather, it's been glued and it's drying. So then we'll come back and look when we get a bit farther.